Good morning, grade 11s and 12s. Today, we are going to start revising circle geometry, and we are going to start at a very important place known as the roadmap, or better yet, where do I start? That is the question that will go in your mind. So, in your question paper, you will get a sketch or a diagram like the one given on the screen, and you will have some information provided, like given a circle with center O, with DF being a diameter. They'll say things like CBA is a tangent at point B, and then there'll be some extra information. They might give the value of one of the angles. They might say CD is a tangent at point D. Just a reminder, we can't assume that a tangent is a tangent. They have to either say it or we have to prove it. And they might say something else like B3 plus B4 is 90 degrees. Now, we need to know where to start in getting a game plan together to establish a way to answer possible questions. Now, your typical question here could be something in the lines of find the size of angle A with reasons, and it will be like 3 or 4 or 5 marks. That's it. That's all you get with the introduction paragraph. So, let us get started. Our roadmap starts with a journey, and with any map, we need a starting point. Now, our starting point. Our first question would be, is the center of the circle given to us? If your answer is yes, well, that's fantastic. Then we can consider theorems 1, 2, and 3. And I just want to remind you, which we will see again later, theorem 7 is related to theorem 1, which is also something you can consider with the center. So when considering theorem 1, we just need to remember the rule around it. Theorem 1 is based on the fact that if the radius of a circle dissects or bisects a chord, then it is perpendicular to said chord. And the same with the converse. The converse says if it is perpendicular to the chord, then it bisects the chord. Now, with theorem 2, we know angle at center equals 2 times angle at circumference. And theorem 3, we know that the diameter would support an angle of 90 degrees, also known as angles in a semicircle. Theorem 2 gives theorem 3 its foundation, because if that is 180, then that has to be 90. Okay, so on our roadmap, we've looked at these three. Now, just remember, we are going to get to theorem 7 with tangents, but you can also consider theorem 7 here at this point in the roadmap. Let's move on. Now, we are going to consider our next portion of the map. So once we've done with the center, or if the center is not even given, either or, we consider concyclic points. Now, that means, are there points on the circumference of this circle? And if there are 4 of them, then we form a cyclic quad. And what do we know about cyclic quads? Well, theorem 4 tells us A plus B will equal 180. Please remember they are supplementary and not, I repeat, not equal. They are supplementary angles. Theorem 5, this is where they are, I repeat, they are equal. And that is the exterior angle of the cyclic quad is equals to the opposite interior angle. I repeat, the exterior angle of the cyclic quad is equals to the opposite interior angle of the cyclic quad. I would like to take a moment to mention that this is different to the exterior angles of a triangle, which we are going to see in a moment. Now, our next theorem, which is theorem 6, tells us that now we are going to have concyclic points again. It looks like a bow tie. Please note, we do not have a cyclic quad here, we have a bow tie. And what that tells us is that these angles will be equal to each other. Okay, and again, all three of these have inverses. So if A plus B equals 180, then this whole thing is a cyclic quad. If this exterior angle equals this interior angle, then this is a cyclic quad.
And so we come to our final part of the first page of the roadmap. And that is, once we've been through these center points, and once we've been through concyclic points options, we ask ourselves, are there any tangents? And if the answer is yes, then great. We look at theorems 7, 8, and 9. Now, a reminder, we mentioned this earlier, theorem 7 and theorem 1 are interchangeable. Theorem 7 is based off of theorem 1, where this chord has simply been pushed down to touch at 1 point instead of 2. And that's where we get theorem 7. And that simply says your radius will be perpendicular to a tangent at the point where the tangent occurs. Then we have, if we have 2 tangents coming from the same point and touching a circle, the line segments will be equal in length. And a personal favorite, we have theorem 9 over here that says the angle between a tangent and a chord will be equal to the opposite interior angle. And the reason for that one is simply tan chord theorem. Again, reminder with the fingers. You go up along the angle and you close the angle. It has been discussed in the previous video. And please do not forget the converses. Converses apply as well, saying that if this angle is 90 degrees, then this is a radius or this is a tangent. There is no converse for theorem 8. And for theorem 9, if these angles are equal, then this will be a tangent. All right.
Right, as promised. We go back to grade 8, 9, and 10 with parallel lines. So at this point in your map, you have discussed the center points of a circle, concyclic points in a circle, and tangents. And now we look, are there any parallel lines given? If the answer is yes, we look at our fun statement. Remember, we have corresponding angles, the armpits of the F. We have co-interior angles are supplementary. Please remember they are not equal, they are supplementary. And then we have alternating angles are equal, our fun statement. So we look for those guys. And once we are done with parallel lines, we see, well, what about triangles? And I just want to remind you, when you have two radii of a circle, you have equal line segments, meaning an isosceles triangle. And what do we know about an isosceles triangle? Angles opposite equal sides. Eh? The angles or the base angles of an isosceles triangle are equal. Then, and as promised, we are now at the exterior angle of a triangle part, where the exterior angle of a triangle is equal to the sum. Please see over here, I said plus. The sum of the opposite interior angles. Please do not forget that one. And how do we identify an exterior angle? Well, if the line of the triangle here is extended onwards, it forms an exterior angle here. Do not consider some knick-knack looking thing where the line comes out here, because there you can see it is not, this blue line is not extended from anything in the triangle. That line extended would go down that way, and this line goes there. So the blue line does not form an exterior angle of the triangle. That yellow line does. Then we are at intersecting lines. So once we've gone through our roadmap and we are at triangles and we still need to look for something, do not forget the obvious ones, the easy dudes. Angles on a straight line, angles around a point, and vertically opposite angles. That's where you have lines that are cutting each other, right? This should be your base form. And this is stuff discussed in primary school. Now, for the fun part, let's go and apply all of this knowledge to the diagram in the introduction. Okay, so we started this video with this sketch or this diagram, and I told you there could be a variety of questions that could be asked. Now, I'm going to start with the first point, the center point. So let's say theorems 1, 2, and 3, I'm going to have in green, all right? And we're going to indicate those angles for ourselves quickly. So we start off with theorem 1. Is the center of the circle given? Well, yes, it is. It is indeed. Now, what do we know? We know theorem 1. I just want to point out, often in your tests, they will not give a point. Like you see here, they didn't give you anything. So we cannot say this is 90 degrees or it intersects because we do not know if these two line segments are equal to each other or if this is 90. We might have to prove it later, but it's not given to us now. So we need to move on. What else do we know? If we had to consider theorem 7 in terms of theorem 1, then we know that this here is 90 degrees. And let's say, for example, they said CD is a tangent, then we would know D1 and D2 is also 90 degrees. Excuse my handwriting. All right, now if we had to look at theorem 2, angle at a center equals 2 times angle at a chord, you might not see your typical shapes here, but I want you to start off at B and F. Maybe pause for a second with B and F and see if you can identify theorem 2. And once you've pressed play, you'll see that if you go from B and F up to angle O, and then you go back down to B and F, and you go up to angle D, then you will see that the theorem holds. It is angle at center equals 2 times angle at circumference. So I just want to write that there quickly. One loop for O1, two loops for D1, just to show that D1 is 2 times O1. You might have a different way of noting it, and that is perfectly fine. This is just for this video and for the whiteboard tutoring. And now vice versa, if you go from point B and D to point O, and then from D and B to point F, we have the same thing. But now we need to be careful not to use notation that might confuse us. So if we look at O2 plus O3, and let us do a squiggly wiggly there from B and D to O. Let's do double squiggly wiggly. All the way to F, where we can do 4 squiggly wigglies to show that it is theorem 2. And then theorem 3, we do know as well. Now, theorem 3, we are going to have to change it up a little bit to a green highlighter because otherwise it's going to get a bit confusing. Anyways, do we see angles in a semicircle here? Yes, we do. We see B3 and B2. All right, that was just for the first grouping, the center points that we discussed. Now in blue, I'd like to discuss the second grouping, which is theorem 4 all the way to theorem 6, right? And please note I'm just using Roman numerals just to communicate this a little bit better. Now, do we have concyclic points? Let's see, we have 1, 2, 3. No, we do not have concyclic points. We've only got 3 concyclic points. We do not have 4. We do have CDOB here, but that doesn't necessarily mean they're concyclic because C is not on a circle. So let's move on to the next one. Do we have tangents? Well, yes, we do, and we just need to color code quickly. So let's make it white for theorems 7 on to theorem 9. All right. So theorem 7 we already indicated with the green 90-degree angles over here, which is fantastic at angle B1 and 2 and angle B1 and 2. Now let's go theorem 8. I told you there are two tangents, CD and CB, so that means according to theorem 8, those line segments are equal in length to make a double stripe. Great, which means essentially that B4, we can do a little white arc over there, is equals to D2. And I just want to quickly call out D1 and D2 is 90 degrees, not D2 alone. Let's just communicate that a little bit clearer because we're going to need this to answer questions. Alrighty. And what else do we have? Well, that is the only one for that time. And we've got one more theorem, which is theorem 9. Now, I just want to remind you with theorem 9, and I told you it is a personal favorite, we have an angle between a tangent and a chord. And if we go up with the one finger over here, keep one over there, and we form our angle to the circumference of the circle over there, we can see the angle. So I'm going to indicate this in white, but I want you to remember that D1 was 2 green arches over there, right? Meaning it was 2 times O1. And B1 is now equals to D1. So now I've made those two arches, and I'm just going to quickly go and tap over this with white over there. So we can see D1 we can get through looking at 2 times O1. Sorry, not 2 times. D1 is half O1, and B1 is equals to D1 because of theorem 9. And likewise, do you see that another angle is formed here between that angle there? So this tangent in this chord, chord DB, and tangent CA, with B4 being the angle, is now going to equal, if you have to go up with your finger there, and just keep the one over here, and then bring it across to F, it's equals to 4 wiggly squigglies, or 1 white arc. So F1, which is 4 wiggly squigglies, can also be 1 white arc. So there we have the 9 circle theorems that we have gone through. If they ask us to prove something is a tangent, we can use this diagram that we filled in here to answer those questions too. But in red, I would like to communicate the last portion of it. Now, the last portion I just mentioned would be our grade 8, 9, and 10 knowledge. And remember, grade 8, 9, and 10, we started with parallel lines. Now, do we see any parallel lines in this sketch? No, we do not. Okay, so we need to move on. Do we see triangles? Why, yes, we definitely do. I want you to look at radii always. Always identify the radii in a circle if you have the center. All right, so we have OB, OD, and OF, which means these three duties have equal length. And I'm using one red stripe to show that. Remember this point here, this little red point, let me use laser. This point here was not given. Otherwise, we could say, oh, whatever that was is also equal. But it wasn't given, so we're going to just remember it, but not note anything. And now, because we have our radii, which tell us that now D1 would equal B3, so let's just put a dot there, not to have too much going on. D1 equals B3. Likewise, B2, let's put a little star, is equal F1. It's like, okay, cool. Why? Angles opposite equal sides, right? So now we can work with those. And if we have to consider the exterior angle of a triangle, if you give yourself a second to take a look at it, well, we could see that this point over here does have an exterior angle of a triangle, but it's not labeled. And I want you to see when something's not labeled, generally what that means is we can avoid it. Otherwise, if you really are persistent on using it, you can label it yourself and use it. However, if it's not labeled, the memo itself will have a different solution. So it is wiser to look for a different solution. All right, let's consider another exterior angle of a triangle. Well, you can see here B4 would be an exterior angle of triangle BAD, but that's going to be a lot to note down. So just keep a mental image of that for yourself. And now we get things like sum of angles on a straight line. There, B1, 2, 3, 4 would be that, and O1, 2, and 3. Angles around a point would be the whole of O. And yeah, there is your roadmap complete. In the next video posted on the Whiteboard Tutoring South Africa channel, I will be answering questions based on this sketch. So please take a look out for that. Have a lovely day, ladies and gentlemen, and God bless.